Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be looking at GCSE Physics efficiency. Now, this is an important topic because later on, pretty much anything we use, whenever it was designed, any product that you have used, whenever it was designed, a lot of them would have been considered for efficiency. Efficiency would be a major consideration when designing many mechanical or electrical products. So that's why efficiency is important. So without further ado, let's get started. Now, the best way to talk about efficiency is through an example. So let's imagine a light bulb, and we have 100 joules of energy going into that light bulb, and then it's giving out light. So out of that 100 joules of energy going into the light bulb, only 20 joules, only about 20 joules goes to light. Now, this may be surprising at first, because the job of the light bulb is to give out light. But 80%, 80 joules of that energy would go towards heat. So it actually doesn't give out light at all. Now, considering that this is a light bulb and that we want light. We don't necessarily want heat from a light bulb. We want light from a light bulb. Then, obviously, heat. In this case, heat would be useless. And light is the useful thing that we want. So, this, by the way, this may be surprising why such a split. Why actually this light bulb is pretty terrible at doing its job. It only gives you 20 joules worth of energy, of useful energy, for 100 joules that you put in. Whereas it gives out so much heat. It's terrible at its job. I mean, the classic light bulbs with the carbon wire inside them, actually, if you think about how they work, this isn't so surprising, because we have this carbon wire going in the light bulb, and then the electric current goes through that wire, and because that wire has a very high resistance, as that electric current makes its way through it, it starts heating up that wire. It starts heating it up to the point that it just becomes white hot, and that's how it releases light. That's how those those classic light bulbs work. So it literally releases a lot of heat by design. By design, it actually releases a lot of heat, which is why this light bulb, we would say that this light bulb is not very efficient, because out of that 100 joules, only 20 joules of energy came out that was useful. That's what we intended. Whereas 80 joules of that 100 joules was useless. It came out as heat, completely useless in this case. So, now, how would we express this? As in physics, we always have some equations. How do we express efficiency of that light bulb? Well, equation goes like this. Efficiency, as we talked, efficiency is equal to useful output divided by total input. Now, this is essentially what we're talking about. The input is 100 joules, and useful output here would be that 20 joules. So essentially, we are, long story short, we are essentially taking a ratio of that useful energy to the total energy, and that's simply how we measure efficiency. So, for example, here we would have efficiency. I'm gonna shorten it like so. So, in this case, our efficiency would be 20 joules of output divided by 100 joules of input. So, efficiency would be 0.2, or in other words, it would be 20%. So, as we can see, mathematically we showed that this light bulb is not very efficient. Now, another way we can show efficiency is, again, using the same concept. This is the most important concept that I'm going to show you today. So, using this same concept, but we can also use power as a measurement. Now, as we talked before, power is a rate of energy transfer. If you don't know about power, check out the link in the description below. There's a video that will explain all about power. Now, power is essentially rate of energy transfer. So, we could also express this using power. If we don't know the total input energy and total output energy, we can use power. We can use the total input power and useful output power. So we could divide useful output power by total input power. That's also how we could calculate efficiency. Now, as you can see, that light bulb is not efficient at all, which is why we are currently, certainly in Europe at least, we are currently pushing very hard to get rid of these guys and to replace all the light bulbs with the energy-saving light bulbs. Now, energy-saving light bulbs work... Now, you don't need to know this for GCSE, but energy-saving light bulbs work by electric currents being passed through gases and a very, very small amount of mercury vapor. And then that excites these gases, which end up releasing ultraviolet light, which in turn hits the inner coating of that energy-saving light bulb, which is covered with a fluorescent compound, which fluoresces when ultraviolet light hits it. And that's how energy-saving light bulbs work. So, and these energy-saving light bulbs, they take more energy to start, but they are about 70% more efficient than these guys. So they're much more efficient, and that's why we are generally pushing more and more to use them. So that's it. That's it for light bulbs. But let's talk about how we can change that efficiency. Now, the best way to talk about how to change efficiency would be cars. So we could, first thing, if we wanted to make a car more efficient. Now, why is there inefficiency in a car and majority of mechanical mechanisms, contraptions? Why is there not 100% efficiency? Why are they not 100% efficient? Well, the main reason for that is friction. The axles on which the wheels are and the bearings that they are in, there's a friction going on between them. So due to that friction, some of that energy is wasted as heat. So not everything is converted from the chemical energy from fuel to kinetic energy. We also lose quite a lot in heat because of these friction forces, because of these axles, because of these friction between axles. And of course, we want to minimize that kind of friction. That's the very first thing we would do in order to try and make a car more efficient. Now, how could we do that? Well, one way we could lubricate the axles. We could lubricate the axles behind those wheels, and that would reduce the friction and make those cars more efficient. Now, also, another way we could do this is we could make the car more streamlined. So if we look at this car, if it's going against the air, there's quite a lot of air hitting it, causing turbulence, and the air has trouble to getting past the car. And what happens is that the air causes friction between the car surface and itself, which releases heat, and which wastes some of that kinetic energy as heat. As you can see, heat is one of the major ways that energy is wasted. That's always the problem. No, it isn't always heat, but very often it's heat that causes this energy wastage. A lot of these useless energies often will be heat, which is why, conversely, electric heater is actually pretty efficient, because it releases heat, and that's its job. It's supposed to release heat. So it's actually near 100% efficient, not quite, but it is near 100% efficient. Anyway, back to cars. So we have that friction, and of course heat is released, and we waste some of that kinetic energy that we generated from chemical energy from fuel. Now, if we look at this car here, we made it more streamlined. It has a better, more aerodynamic shape. So what that means is that air has easier time getting past the car. It just gets past the car easier. So there is less friction, and therefore less heat is generated, and therefore we wasted less of kinetic energy. So this car would be more efficient than this car. And of course there are ways of making engines more efficient, the way they pass fuels and things like that. But those are the two simplest ways we can improve the efficiency of a mechanical contraption. We can either lubricate the axles that cause friction, or we can make the mechanical machine contraption, for in this case car, more streamlined, so it has less trouble getting past the air. So this is it for today, guys. Thank you very much for watching. I really appreciate every time you guys watch these videos. If you want to stay up to date on daily science, maths and biomedical sciences videos, hit that subscribe button below. If you like this video, give me a big thumbs up. And if you got any questions, any at all, ask me in the comments. I am more than happy to help you out. Thank you again, and see you next time.